Morning, students. Let's start the new topic of electrochemistry today, fuel cells. So, as it is the theory topic, that's why I am explaining this topic like this from the NCERT textbook only. See here, in the last video, I given the batteries explanation. So, their electricity is producing by using chemicals there. So there also redox reaction is going on, means reduction and oxidation, both reactions are going on there and producing electricity. So like that in fuel cells, so we have to use some fuels. So fuels generating electricity in these cells now. That's why the fuel cells can be defined as the cells in which fuel gases are generating electricity. They are called fuel cells. Here, these fuel cells generally some plants, the chemical energy of fuels, fossil fuels, means here the matter is given. See, in this matter, the first used for converting water into high pressure steam, and it is then used to run the turbine to produce electricity. So these are all thermal power plants, means by using the water and all high electricity producing we can see by using the turbines. So they are all called as thermal power plants. Similarly, the coal gas and oils also we need to use here in the fuel cells to produce electricity. So the definition of fuel cells we can write it as, see, the galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc., directly into electrical energy are called fuel cells. Means which fuel gases are using here means hydrogen, methane, methanol. So these gases when we are using, and we need to use this diagram also in this. For example, hydrogen I am sending from this, and oxygen I am sending from this. Hydrogen and oxygen I am sending from this. So how electricity is generating from this diagram I will explain. So here also anode is required, cathode is required. See here, one of the most successful fuel cells uses the reaction of hydrogen with oxygen is given in this diagram. Here, this experiment, this oxygen and hydrogen experiment, was used in the Apollo series of rockets for generating the electricity. See how they have used and to generate the electricity in Apollo series of rockets, how they have used, I will explain now. See, this is one diagram for generating electricity. In this, hydrogen is sending from the left side, and oxygen is sending from the right hand side like this. So here this part is acting as anode, and this one is acting as cathode there. So here also anode, cathode compulsory required in this. See, when hydrogen and oxygens are used, generally we know water only producing. See here water is producing. This water is a pure water, and the astronauts in Apollo series of rockets are used to drink this water also. That's why the pure water is forming in this. See here what they used in this cell, hydrogen and oxygen are bubbled through porous carbon electrodes into concentrated aqueous sodium hydroxide solution. Here the catalysts like finely divided platinum or palladium metals are incorporated into electrodes for increasing the rate of electrode reactions. Means here the rods, carbon rods are using there. One is acting as anode, another one is See here the carbon rods, one is acting as cathode and another one is acting as anode. This is anode and this is cathode. So through this area hydrogen gas is sending, and through this area oxygen gas is sending there. And to increase the speed of the reaction, here the finely divided platinum or palladium rods also using in that. See the reactions, how they undergo and how they generating electricity, I'll tell you. See at cathode, so which one we have taken as a at cathode means oxygen we are sending. So oxygen undergo reduction there, means gaining of electrons are going on at cathode. So what happened? This oxygen, water, and the gaining 4 moles of electron, releasing 4 OH minus ions there. Now at anode we know oxidation is going on. At anode here water H2 is taken. So this H2 combines with OH minus ions coming from the above are adding and releasing 4 moles of electrons there and giving water also. So the overall reaction, if you add all these two, here 4 OH cancel, 4 electrons cancel, and out of the 4 water, here 2 H2O also cancel. So the overall reaction will be 2H2 plus O2. See, 2H2 plus O2 gives 2H2O. So this is actually overall reaction in this. But here the very important point in this is the cell runs continuously as long as reactants are supplied. So fuel cells produces electricity with efficiency at about 70% compared to thermal power plants there. So whatever the thermal power plants are there, along with thermal power plants, see thermal power plants are producing 40% only. But here when compared to thermal power plants, these fuel cells are giving 70% only there. Means the 70% efficiency of current is producing in the fuel cells, but in the thermal power plants 40% efficiency only producing. Means the fuel cells are giving high efficiency current, this point only giving there. And for using of this fuel cells now, it is pollution free. That's why, and again high efficiency also coming. Therefore fuel cells have more fabricated and tried is given there. And the last topic in this is corrosion. The corrosion also, here also electrochemical process only going on, means oxidation, reduction, both are going on there. See, this is iron rod, let us take. The iron rod becoming, on the iron rod you see generally the rusting is possible. How the rusting is possible on the iron rod, it will explain in the corrosion part. Corrosion means destroying of the any material. See, corrosion slowly coats the surface of metal objects with oxides or other salts of metals. The rusting of iron, nothing but other examples of corrosion is rusting of iron, tarnishing of silver, development of green coating or copper on copper or bronze, and some of the examples are of the corrosion also. Means silver gets tarnishes and over the copper vessels the green coating also possible. So these are all examples of the corrosion we can say. So it is because of the corrosion, no, it causes enormous damage to buildings, bridges, ships, and all other objects made of metals, especially that of iron. So because of this rusting, no, the life of the bridges and buildings will decreases. Therefore, we need to protect these things from the rusting. So how it is protecting, I will tell you. Before that, how this rusting is possible, I will tell you now. See, in the corrosion part, means the rusting of the iron. So for this now, here also one anode, one cathode is required. See here, whatever the iron rod is using there, this is acting as anode itself. That's why at anode the iron is undergo oxidation. So that's why two irons are forming 2Fe2 plus and 4 electrons are releasing. The electrode potential for this single electrode itself is this one. This is electrode reduction potential value, but it undergo oxidation only, but here reduction potential value is mentioning there. And whatever the electrons are releasing, see this, Fe releasing 2 electrons, here also second Fe releasing 2 electrons, so totally 4 electrons are coming there. The electron releasing by the two metal atoms are gained by atmospheric oxygen, see, atmospheric water. The atmospheric water 2H2O gains these 4 electrons and releases 4H plus and O2 there, 4H plus and O2. So this is important and it can be shown here also, see. Now at cathode, see, cathode we have the oxygen from the atmosphere. So this is green color part is atmosphere. In this atmosphere you will get the moisture, air water moisture, and we will get the oxygen also. See, at cathode the oxygen gains the H plus ions from the moisture and gains the 4 electrons from this above anode and showing 2 moles of water. For this also reduction potential value is given there. So H plus becomes water, reduction potential value is given. Therefore 1.23 volts current is passing in this. So if you add this anode reaction and cathode reaction, overall reaction, here 4 electrons will get cancelled. So the overall reaction will comes like this. So the EMF of the cell, we can take E cathode minus E anode, means 1.23 minus of minus 0.44, you will get 1.67. As E naught value positive means this reaction is feasible. So here overall all reactions are giving here, oxidation it is going on here, reduction here going on, and atmospheric oxidation overall reaction is this. So totally all explanations are given. Now here whatever the iron is converted to the Fe2 plus, these Fe2 plus further oxidized to ferric ions. I will show here. See, whatever this Fe2 plus ions are forming, see here Fe2 plus, here Fe2 plus. This Fe2 plus, see, again converted to Fe3 plus there. Again losing of electrons takes place. How? This Fe2 plus combines with oxygen, see, forming Fe2O3. Here this is the rust color. So Fe2O3 is forming. How? Whatever the Fe2 plus ions combines with atmospheric oxygen forming Fe2O3. This is the formula of rusting there. This point is given. The ferrous ions are further oxidized to atmospheric oxygen to ferric ions, which comes out as the rust in the form of hydrated ferric oxide. See, Fe2O3 XS2O is the rust formula. So like this way, corrosion, anode oxidation is going on, cathode reduction is going on, overall reaction is going on like this. So it is also rusting, means corrosion process also we can take in the example for the oxidation reduction reaction, nothing but electrochemical reaction in this. So this is the total E naught of the cell in this. I told you we need to prevent the formation of corrosion, therefore the life of the constructions will increase. So the prevention of the corrosion is very, very important. Here direct exposure of this iron rod will get corrosion. That's why, so we have to do some coating on this iron rod. That's why any iron gate ho, any iron window ho, so compulsory painting should be done on this. The painting is protecting the inside iron from the rusting, because in these paints now highly active elements than the iron is available. Highly active elements than the iron is available. Therefore, so those elements get undergo oxidation. Therefore, inside iron will be safe from the rust. Therefore, prevention of the corrosion is a prime important. It is not only saves money but also helps in protecting the preventing the accidents such as bridge collapse, money, but also helps in preventing collapse or failure of the key component due to the corrosion. One of the simplest method of preventing corrosion is to prevent the surface of the metallic object to come in contact with atmosphere. This can be done by covering the surface with paint or by some chemicals, means bisphenol. So these chemicals also we can use to prevent this inside iron. So another simple method is to cover the surface by other metals or tin, zinc that are inert or to react to save the object. An electrochemical method is used to provide the sacrificial electrode of another metal like magnesium zinc, which corrodes itself but saves the object. That's why this process is known as galvanization. Everybody have to note down. This process is known as galvanization. Means the iron objects can be prevented from the rusting by paint by using the zinc. If you use only the zinc element, then we can say it is the galvanization. So this is about the rust formation. Total diagram is explained like this. Here iron atoms loses 2 electrons there, 2 to 4 electrons are going on, and iron say electron lose ho gaya to here Fe2 plus and here also Fe2 plus ions are forming. These Fe2 plus ions combines with atmospheric oxygen to form Fe2O3, and these 4 electrons are these 4 electrons combines with H plus ions and oxygen from the air, forming water there. So with this water and Fe2O3 becoming rust there. This is totally process. That's all. And here some in-test questions are all there. These in-test questions and all we will do in the live class. That's all. The electrochemistry totally it is finished. And for the exam के लिए all in test questions, exercise questions you need to read. That's all today. Thank you.